Hi everyone, Miss Colasso here. So in this short video today, I am going to review the 3.4.3 lab for Apex. So I understand that this lab could be pretty tricky because the very first question asks you to create a graph. So I went ahead and I quickly created that graph for you all. So this graph that I created, I'm going to make that shareable so that you all could copy and paste that into your practice, just because right now we don't have the resources to make physical graphs, and I know that this could actually take a long time to figure out how to do if you haven't had experience making graphs. So that's going to be there for you. So for this video, I'm going to kind of walk you through interpreting and analyzing this graph and being able to answer the lab questions. So in the lab, they kind of discuss situations where it's all about natural selection and environments where these bears, the dark and light bears, can either be at an advantage or disadvantage. So what this lab is talking about is very similar to the natural selection video that I put in our Google site, the simplified video, where I kind of demonstrate the exact same thing but with pieces of paper. So if you want to watch that too, just to gain some background knowledge, I definitely recommend that. But so for the purpose of this lab, they're essentially doing that same experiment where, like I said, in some situations, the dark bears are at an advantage, and in some, the light bears are. So this is the graph that you would get if you calculated all of the data points that you'll see. So I'll actually go back to the practice and show you. So I basically took this chart and I converted it into a graph that we could use to answer the questions. So right away, we're asked to summarize the trends we see in a population. So just thinking about a trend, that's something we're going to see across the entire graph. So right away, one of the biggest things that stands out is that these dark bears have a marked increase. Do you all see how that blue line, the dark bears, just really increases over the generations? So on our x-axis, we have the generations. On our y, we have the number of bears. So we could see that trend of an increase. So for dark bears, you could write that there is an increase in bears over generation. For the light bears, however, this looks a little different because, it's a little steady in the beginning, but there's still an increase. Then between generations 5 and 6, there's a decrease. And then from 6 to 10, it increases again. So you could write that. You could say there is an increase between generations 5 and 6. There is a decrease. Then the population begins to increase again after the 6th generation. So that's an example of what you could put. Obviously, you can make it sound a lot more formal. I'm just writing it this way to keep this video kind of short. So that's how we would see the trends here. And now that's going to help us answer the next few questions. So how would this experiment demonstrate natural selection? So in natural selection, you're going to see this happen all the time, where some populations may experience a decrease, others may experience an increase. So it kind of mimics natural selection because we're seeing that some populations are at an advantage due to environmental circumstances, whereas another population may be at a disadvantage because of those circumstances. All right, so that's what's happening in natural selection. And again, I really encourage you to watch my simplified video to really understand the situation that's happening with this lab. But I just want to keep this video to really just working through this lab. So next question, if the environmental situation changes, is it possible for a population to be restored? So let's say that in this case, right, So our dark bears are increasing. Now let's say that for some reason the environment changes and there's a fire and there's no more trees. So those dark bears are now exposed, right? So that might cause hunters to, be able to find and hunt the bears, the darker bears, whereas the lighter bears might be able to blend in a little bit more with dry patches of land. So we're going to see a decrease in dark bears. Now that's just a situation, but we could say, yes, that population may decrease, but our light bears might actually increase from that because they're not going to be hunted as much as the dark bears. So if the environmental situation changes, is it possible for our population to be restored? You could just say yes. How can natural selection help explain how a population becomes extinct? So that was like I was saying before. So if over many generations, more individuals of that population are dying and disadvantaged, they will not be able to pass on their traits and inevitably become extinct. Okay, so that's what happens. So let's say our scenario again with the black bears or the darker bears. So now let's say that they're going to be hunted more because, their environment isn't as dark as it used to be. They can't blend in. So now that population over generations is going to start becoming extinct because they're going to be hunted more than the light bears. Okay? Which generation saw a population altering incident? Use your imagination to invent a possible environmental incident that could have caused a shift in populations. So I kind of just already said this for you guys. So which generation saw? So we talked about this. So the 5th and 6th generations of light bears, right? Because we could see that up here. We see this drop between the 5th and 6th generation, right? So we could say that they were affected. Were affected. This could have been. So now let's think why light bears would be affected. So let's say that maybe there was a lot of pollution in the area that turned it a lot darker. So now these lighter bears are going to stand out. So we could say it could have been from pollution in the environment that made the surroundings darker, allowing the lighter bears to be easily hunted, causing a decrease in population. Okay, so that's just an example. You can use your imagination to come up with others, but that's one that makes a lot of sense to me. How can the environment impact a particular population of a species? So this is kind of asking a very similar question. Basically, one way is that if that species is not able to blend in with the environment, predators are more likely to get them or see them and be able to capture them. So you could say if the species is not able to blend in, they may be at a disadvantage because predators can easily find them. Okay? What are some natural reasons that animals in a population might die? So, some natural reasons could be sickness, trying to think what else. Natural disasters. So you could put like a flood, fire, volcano in some areas, okay? I don't know if the naturals also, so maybe we could even put like predators. What are some man-made reasons that animals in a population die? So we could say deforestation, right? And pollution. Those are two big reasons why animals in a population might die. So you all have seen those really sad soap commercials, the Dawn soap, where, animals are just covered in oil and they could be dying from that pollution. We know that deforestation, so taking down trees, is taking down the homes of certain animals. So that could cause them to die if they have, no protection, right? No shelter. So the last question, what are some ways that man has helped animals maintain their populations? So one that I've been explaining to a lot of you is called an ecological preserve. I don't know if this is necessarily the most correct answer, but to me, that's really an important way that animals in the population are really protected. So you could say it protects animals from being harmed. So ecological preserves, people are not allowed to build on that land. They're not allowed to have pollution in that area. So it's really just like a very safe place for these animals. So that's a good one. You could also do your own research and kind of find out some more. But that's, I just wanted to kind of walk you through this very simply. So I hope this helps. Feel free to, pause this video at any time, rewatch it to help guide you through the lab. But if you have any questions, please let me know as usual. All right. Thanks, everyone.